Hello everyone, this video will be dealing with question 3 of distributions review.
So question number 3 asks us to calculate the probability of the following events for a distribution with a mean 10 and a standard deviation 5. So before beginning to calculate the values, I will go over what a normal distribution is and how we use z-scores with probability. A normal distribution is a symmetric probability distribution that is characterized by a bell-shaped curve. So the bell-shaped curve is determined by the mean and the standard deviation. About 68% of the data falls within one standard deviation of the mean, 95% within two standard deviations, and approximately 99.7% within three standard deviations. Z-scores are a statistical measurement that describes a value's relationship to the mean of a group of values. A z-score describes the position of a specific value within a distribution in relation to the mean of the distribution. So here we have the equation to calculate a z-score where a data point, or x, in a dataset is subtracted by the mean and then it's divided by the standard deviation. After calculating the z-score, we use this chart to locate the z-score in the rows and columns of the chart. The rows typically represent the whole number part of the z-score, and the columns represent the decimal part. The chart will provide the cumulative probability associated with the z-score, and this represents the percentage of data points below the given z-score in a standard normal distribution. A positive z-score indicates that the data point is above the mean, while a negative z-score indicates that the data point is below the mean. The magnitude of the z-score tells you how many standard deviations away from the mean the data point is.
From the question, we know that our mu value or mean is 10 and the standard deviation value or sigma value is 5. So the first part of the question is probability of x lesser than or equal to 12. The second part is probability of x greater than or equal to 22. The third part of the question is probability of x which is greater than or equal to 2 or less than or equal to 12. Here we are looking to find the probability that a random variable x is less than or equal to 12. Z is a standardized value which can be calculated by Z is equal to x minus mu by sigma. Here mu is already determined to be 10 and sigma is given as 5. So the final calculation gives Z as 0.4. Finally, using a standard normal distribution table or a calculator, we find the probability corresponding to a z-score of 0.4. This probability represents the area under the normal curve to the left of z is equal to 0.4. In this case, the probability is approximately 0.6554, which means that there is a 65.54% chance that a random variable x is less than or equal to 12.
In this question, we aim to calculate the probability of x being greater than or equal to 22. First, we determine the z-score using the given value x equal to 22, subtracting the mean, which is 10, then divided by standard deviation 5. This calculation yields a z-score of 2.4. Consulting the standard normal z-table, we find that the cumulative probability up to a z-score of 2.4 is 0.9918. This value represents the area to the left of z equal to 24 under the normal distribution curve. To find the probability of obtaining a value of 22 or higher, we subtract the cumulative probability from 1, which represents the total probability. Therefore, the probability of encountering a value greater than or equal to 22 in this distribution is 0.0082.
The z-score for given value x from a normal distribution with mean mu and standard deviation sigma is calculated using the formula z is equal to x minus mu divided by sigma. For x is equal to 2 with mu is equal to 10 and sigma is equal to 5, the z-score is z is equal to 2 minus 10 divided by 5, which equals to minus 1.6. And the same formula when applied to x is equal to 12, the z-score is 0.4. So, finding the probability between z-scores, the probability P is represented by A is less than or equal to x and x is less than or equal to B, which is equivalent to minus 1.6 is equivalent less than or equivalent to z, and z is less than or equivalent to 0.4. Using the z table or calculator, we find that z less than or equal to 0.4 is almost equal to 0.6554 and z less than or equal to minus 1.6 is equal to 0.0548. So calculating the probability, which is p minus 1.6 less than z or equal to z, whereas z less than or equal to 0.4 is equal to 0.6554 minus 0.0548 is equal to 0.606. So the probability that the x falls between 2 and 12 in a normal distribution with mean mu is equal to 10 and standard deviation sigma is equal to 5 is approximately 0.6006.